You see another one. It always come very simple. It always look very simple, but tricky. Evaluate 8 divided by 4 mod 12. If you don't know much about moduli, you quickly say 8 divided by 4, 2. You say 2 mod 12. And a question like this, you could have up to what? 3 different integers as your solution. So in any exam, if you do that, even the examiner, once you look at what you do, he or she already know that you don't understand the topic in question, and automatically you score 0. So you have to keep attention to this and grasp all the points that are what very germane as far as this subtopic under this particular modular arithmetic is concerned. Now let's look at it critically. We have solution 8 divided by 4 mod 12. The first thing, like we said, is to check the GCD, and you always check GCD between the divisor and the modular. Here, GCD is what? 4, 12. Now, what is the greatest common divisor here? It is 4. And remember, we said when the GCD is not 1, the easiest way to solve such what? To simplify or evaluate is to use CRT, which we said in the previous video. And the GCD here is what? 4. That means it is greater than 1. So D is what? 4. And this implies that our solution is more than 1. We have 4 solution. Now, there's a point I also want us to know. A, name them out. We say A is your divisor. In this case, A is 4. B is dividend, and B here is what? 8. M moduli is 12. We said before we use CRT, take note of this. Before we use CRT, the what? The dividend must be less than the dividend, which is B, must be less than moduli. By going by this, that 0 is less than or equal to B, B is less than M. Take note of this, because if our B is not less than M, we'll have to reduce the B. In the next video, we're going to solve a question where originally the B is higher than the moduli. Then we'll show you how it is being done. We're just for now, let's concentrate on how to understand how to evaluate the division in moduli when the GCD is greater than 1. I just chip this one in for us to know that there could be a question whereby the B is greater than the M, and for you to use your theorem, you have to reduce the B. Take note. Now, going back to our question, we have the theorem. The difference between the divisor and the dividend is equal to multiple of the moduli. K is the multiple. Now, GCD is more than what? 1, so there's every reason to have this X. X showcases what? You have more than 1 solution. Now, B is 4. If you rewrite this using this particular arrangement, A, we have what? A here is what? 4x equal to, bring this B to this side, and B is what? 8 plus what? M is what? 12. So we have 12k. Remember, we said for the expression, note this, to have solution, the equation must be divisible, must be divisible by the GCD, must be divisible by the GCD. So in this case, pardon please. In this case, the GCD is 4, and it can go, our equation is 4x equal to 8 plus 12k. It can divide it. So here you have what? X equal to what? 2 plus 3k. 2 plus 3k. So, had it been, it is not divisible by what? It is not divisible by this particular 4, then our conclusion would be there is no solution. Before, in the next 2 or 3 videos, we have a question of this nature that has no solution. We will understand it better when we get there. Just make sure you are following us on our Facebook page, the YouTube, the TikTok handle. You will get every detail as far as this topic that we are currently doing is concerned. Okay, now we have to, here is 1x. We have to look for the inverse. Remember, you said your GCD, which is what? 4, 12. Once it's divided by 4, you are now left with what? 1, 3. Here, GCD has become 1. So we have to look for what? What inverse of what? An x that will give you what? 1. That will give you what? 1 mod 3. So we have to start. We say, okay, 1 times 1 is 1. 1 times 2. 1 times 3. 1 times 4. Now, what we are saying, 3 and 4, we have 1 remainder 1. So, the inverse of what? An x that gives us 1 mod 3 is 4. Is 4. So, automatically, we can say 1 times 4x is equal. Remember, the inverse always cancel out the coefficient, any kind of coefficient attached to the x. So it means this 4 take away this 1. So we have 4 times 2, we have 8. Remember, you are dealing with what? Modular 3. So 3 in 8 gives you what? It will give you what? 2 remainder 2. So we have 2 plus, we have to have 3 times 4, 12. But remember, we change the 3k to what? 3t, because these are all multiples of what? 3, irrespective of what? The number you are using to multiply this 3k, it will still give you what? Multiples of 3. To showcase that the multiple has changed, we change from k to t. Now, you have what? X is equal to what? 2 plus 3t. We fall back to what we had here. Okay? Now, remember GCD originally gives you what? 4. So we are working with what? T was 0, 1, 2, 3. Now, at x equals to 0, I'm used with this x equal to 0. Sorry, it is t. At t equal to 0, x equals to what? 2 plus 3. So you have 2. At t equals to what? 1, x equals to 1, 2 plus 3 into 1, you have 5. Now, at x equal to what? At x equal to what? 2. At t equal to 2, x equals to what? 2 plus 3 into 2. We have 3 times 2, 6 plus 2, that is what? 8. Let's make use of this short space. At t equal to what? 3, S equals to 2 plus 3 times 3. 3 times 3 is 9 plus 2. That gives us 11. So X equal to what? We have the first value here, 2, 5, 8, 11. We can now see that what? Simple question, 8 divided by 4 modular 12 has a solution of what? 2, 5, 8, 11. This confirms to us the difference between your algebraic division and modular arithmetic division. Make sure you continue to follow us on our Facebook page, Amino Maths Class, on our YouTube channel, and Instagram handle, at the same time our TikTok handle, to enjoy more of this interesting question. In the next video, we're going to give you a question whereby the dividend is higher than the modular. We'll show you how to unravel such enigma. Thank you and bye-bye for now.